Hello, my name is Ahmad Syahidi bin Rosli. My metric number is AA200106. I will present about the introduction. Shear force is defined as an internal force that is usually caused by any external force that acts perpendicular to the material and opposes a force that acts in the opposite direction, or is simply known as offset force. Okay, next, for bending moment is defined as the metric of the bending effect that may occur when a structural member is subjected to an external force. Okay, next is theory. This is the types of the beam. First, simply supported beam. Simply supported beam is a beam with no moment resistance that is supported on both ends and is free to rotate. Second, overhanging beam. Overhanging beam is a beam that is supported on both ends and is not allowed to rotate. Next is cantilever beam. Cantilever beam is a projecting beam with only one end fixed. And the next is continuous beam. Continuous beam is a beam that spans more than two supports. Next is fixed beam. Fixed beam is a beam that is supported on both ends and is allowed to rotate. And the last is prop cantilever beam. Prop cantilever beam is a beam that is fixed at one end and simply supported at another end. There are four types of load. First, point load. This load acts in one position only, whether in a vertical or inclined direction. Second, uniformly distributed load. This load is applied evenly over a distance of support. Next is uniformly varying load. The magnitude of his load will vary along with the distance of support at a constant rate. And the last is point moment. Point moment is resulting load made by a pair of force. This force will create a moment on the point of loading. As you can see, this is the diagram for shear force and bending moment.
Hi, my name is Amirah, metric number AA200188, and I will continue the presentation with methodology, which will discuss about the background of case study, application of concept, and application of software. First, let's start with background of study. This study is about the cantilever type of parking bay. The cantilever car parking was built to provide shades for the vehicle to prevent the vehicle from adverse effect of elements of weather such as sun, rain, and heat. This cantilever car parking bay usually be found at many big supermarkets, railway stations, or hospitals. The cantilever is available in a variety of different materials which depends on the location. And the objective of this case study is to construct shear force diagram and bending moment diagram for beam AB for the cantilever parking bay. To analyze the structure, we draw the cantilever parking to more understandable illustration, and then we evaluate the required variable, for example, the height and the applied load. From the observation and evaluation, we assume that the roof is supported by beam AB, which is rigidly connected at point A, fixed end, while point B is left as free end. The uniformly distributed load acted on the beam by the roof is given as 0.5 kN per meter, while the length of the beam is 4 meters. Based on the information given, we construct the shear force diagram and the bending moment diagram for the beam AB. Next, the application of concept. The application of moment cancel in cantilevered beam is by replacing the uniform distributed load, if there's any, with equivalent point load and solving sum of moment about support A, so direction at support B can be determined. Then by solving the summation of moment about support B, direction at support A can be determined, as bending moment at any given section is equal to the sum of the moment at the section of all loads between sections and the free end of the cantilever. The stress in a beam can be determined by moment equals to the moment produced by the stress distribution about the natural axis. And the application of a shear force diagram of the cantilever beam is the graphical representation of the variation of the shear force along the length of the beam. Meanwhile, the application of bending moment diagram is the graphical representation of the variation of the bending moment along the length of the beam. Equation of equilibrium, which sets the external applied load equal to the sum of the internal element force at all joints of the structural system. The concept of the theory applied in this case study is finding the variation of the shear and moment in the cantilevered beam. Next, the application of software. Canva is the one of the software that is utilized while conducting this case study. Canva software is used to create an illustration of the real situation of the case study. This is to create a more understandable illustration rather than the actual picture. In the illustration, the properties of the cantilevered beam are illustrated, such as the length and the load acting on the beam. This way, a better understanding can be obtained, and the analysis of the structure can be examined precisely, and the shear force diagram and the bending moment diagram can also be determined perfectly. Next, Microsoft Excel, which is utilized for generation of the shear force diagram and the bending moment diagram. The software used can be precisely calculate and grow the slope for both of the diagrams by keying in the data of the experimental calculation to the Excel spreadsheet. It's very helpful that the diagram can be computed and have generated diagram.
Hello, my name is Chan Junwei. Now let's discuss and analyze the case. To analyze the case, the first step we are going to do is draw the free body diagram of the beam. So the free body diagram will as shown top left side. We are going to convert the universal distributed load to point load. By calculation, we get the W is equals to 2 kN. Hence, the free body diagram will become like this, where the 2 kN is located 2 meters away from point A. The second step we're going to do is calculate the support reactions at point A. By using the equation of equilibrium, we can get AX equals to 0 kN and AY equals to 2 kN. The third step we can do is to calculate the shear force. To calculate the shear force, we will take a random cut sections at an arbitrary distance from point A, extending within the region AO. By applying summation of Fy equals to 0, we can get the V is 2 kN, where this is the shear force at point A. Next, we're going to calculate the moment of A. By applying the moment equations, we can get the moment at point A is 4 kN. Since the shear force at point A is 2 kN, therefore, we can construct a shear force diagram now. Since the load is a universal distributed load, the shear force diagram will look like a decreasing slope line, where it will decrease from 2 kN of shear force to 0 until we reach 4 meters of beam distance. Therefore, we can construct equations for the graph of shear force. The first thing we do is calculate the gradient of the graph, where negative delta y over delta x is equals to negative 1 over 2. So this is the gradient of the graph. Then our y-intercept should be 2. Hence, we will get an equation of v equals to negative half x plus 2. And these equations can help us to determine the shear force at any location of this beam. For instance, if we want to find the shear force at beam distance of 2 meters, where x equals to 2, we can just substitute 2 into the equation and we will get 1 kN. Next, we're going to find the bending moment. By using the same card, we consider the total moment of a segment is equals to 0, where summation of m equals to 0, and we'll have a moment at point A and also a internal moment at the right side of the card, where m plus MA is equals to 0, and we assume the internal moment is acting anti-clockwise. Then we can get M equals to negative MA, and we just substitute the value of MA, which is 4 kN, into this equation, and we will get M equals to negative 4 kN meter. Since the magnitude of M is negative, hence the moment of M will act in clockwise direction, which is downwards, where the beam will tend to bend upward. Hence, we can now construct a bending moment diagram. Since the load is uniformly distributed load, the bending moment diagram will look like a parabolic shape, where it will increase from negative 4 kN to 0 until it reached a beam distance of 4 meters. For your information, the change in bending moment can be expressed as the area underneath of shear force graph, where delta M is equals to integrate of Vx dx with upper limit of x and lower limit of 0. By substitute the equations of shear force graph into these equations, we can get delta M is equals to integral of negative half x plus 2 dx with upper limit of x, lower limit of 0. By solving this definite integral, we can get delta M is equals to negative 1 over 4 x squared plus 2x, upper limit of x and lower limit of 0. So this is the equations that we can use to find the change in moment at any distance of beam. For instance, when we want to find the change in moment when the beam is located at 2 meters, we can just substitute the value into these equations, and we will get the delta M is equals to 3 kN meter. Then we just add this value with the original bending moment at point A, which is negative 4 kN. The bending moment at x equals to 2 will become negative 1 kN meter.
As a conclusion, bending moment is the reaction induced in a structural element when an external force or moment is applied. The bending moment concept is essential in structural engineering, where it can be used to examine and predict the reaction force. Shear force diagram and the bending moment diagram can be determined by analyzing the structure by utilizing many software that helps us to get a better understanding of the cantilever structure. That's all for our group. Thanks for watching and have a good day ahead.